Hi, my name is Alethea Bear. This is my video to accompany my paper for the class Science, Technology, and the Environment, and I hope you enjoy it. Fossils, a look into the process of fossilization. Fossils are found all over the world in hundreds of shapes and sizes and states. They can be found at the top of mountains and deep at the bottom of the sea. They're found anywhere from the size of tiny little cells to the size of huge dinosaurs. But how do they get there? How did they change from a living, breathing creature to an almost stone-like object that we can find and study millions of years later? My video is going to answer these questions, but before it can, I need to ask one more question. Just what is a fossil? A fossil is the preserved remains of an organism. Preserved remains of humans and animals are largely made up of teeth and bones because they are stronger than the other parts of the flesh, while the remains of plants are usually wood of tree trunks or logs, such as the petrified forest in Arizona. To actually become a fossil, certain circumstances have to be in place at the time of death and afterwards. Because of this, fossilization is actually a very rare thing to happen. In the best conditions, an animal will die in an environment where it will not be affected by outside forces that will diminish the ending fossil, such as bones being scattered by wind or rain, or the bones being picked at by other animals or bacteria. But even if these remains remain intact, they can still be destroyed if left on the surface for long periods of time. The best chance an organism has, either living or dead, of becoming a fossil is if it is quickly and completely encased, possibly in a mudslide, tree sap, or even glacial ice. These fossils are found just as they were in life, with the same composition and appearance. Now that the question, what is a fossil, is answered, we can finally move into the processes of how organisms actually become fossils. Most fossils found in the world are not made of the original substance of the animal. What I mean by this, for example, is, say, the bones of a deceased animal have, in time, been replaced and turned to stone through a process called permineralization. To put it another way, permineralization is a process of fossilization in which mineral deposits form internal casts of organisms. In this process, after death and burial, the minerals in the animal's bones are slowly lost. As the minerals are lost from the bones, they are refilled with similar minerals from the sediment the animal is buried in. Sediment, as defined by the Encarta World English Dictionary, is material originally suspended in a liquid that settles at the bottom of the liquid when it is left standing for a long time. When the water in the sediment dries up, the minerals are left behind in the remains of the animal as a solid coating in the bone cells of the animal, and as this process repeats over time, the minerals build up until they completely fill the cells and rebuild the bone in this way, turning it into stone. While I have repeatedly said bone is focused on in this process, the minerals can also fill any empty spaces in the body, spaces that in life that were filled with gas or liquid, and such as this picture of a trilobite. The whole organism is preserved. Moving on to the next process of fossilization, this is the process of molds and casts. If an organism is trapped in some sort of casing, such as a rock, there is a possibility that the original remains inside of the rock could decompose, dissolve, or be destroyed in some other manner. What is left would be an organism-shaped hole in the rock known as a mold. A cast is created if something fills this mold, similar to permineralization when another mineral comes in, as seen in these next few pictures. Cartage.org had a wonderful visual of this process of mold and casting. In their example, they use a shell rather than the skull of an animal or the bones. I'm just going to read what the website put next to these pictures to explain them. Picture 1. After death, the animal is buried, and natural openings in the shell allow the space formerly occupied by fleshy parts to be filled with sediment. Picture 2. When the enclosing sediment has turned to rock, impressions are made of both the interior and exterior of the shell. Should the shelly matter now be dissolved away, internal and external molds would be formed. And picture 3. Mineral solutions percolating through the rock can deposit solid matter in the cavity formerly occupied by the shell. This produces a cast of the original shell, rather similar to the process of making a plaster cast of an object from a mold. Interestingly, if the skull of an animal is turned into a mold, the exact size of the brain can be determined by the cast. This type of cast is called an endocast. This is possible because the cast would be an exact replica of the cranial cavity, which then could be measured to find the brain size. So now you know 2 different ways that fossils are formed, which I'm sure is 2 more than you knew before. The world of fossils is so vast and varied that this has only touched on a tiny, minute corner of all of the different facets of fossils, whether it be the process of fossilization or what we can learn from them. Nevertheless, I hope my video has been informative and enjoyable, and thank you for watching.